Brown Dog Gadgets live.
I'm watching myself on two different things on my phone and
we
on
appear
here.
to be live.
There we go. Let's be done with sharing things on Facebook. Hi everybody, it's Brown Dog Gadgets live.
It is.
Live.
Hello, Cat.
Cat Science Club. Thanks for watching us. We know you're on there because you're our favorite cat who watches us. Anyway, hey.
It is. The music is.
Our video guy Ben had several music choices. The first one of which kept getting flagged by Facebook as being like copyright issues.
Right.
Even though it was a free to use music file used
That
by
happens.
many things. So good
That
times. But hey,
happens.
it is Tuesday, I believe. I'm
It is,
assuming
yeah.
it's Tuesday. We're here doing another fun STEM project, something that Pete just posted minutes ago on our website. We're going to make a little light up piano, which is green screening.
Yeah, there's a little green on there.
I'm green screening out my own backside here. We're going to make our own fun little piano using clothespins, an Arduino, some of our maker tape, and a piezo speaker. It's a variation of a project we're doing for years with a different touch piano. Basically, it's an Arduino piano with a piezo speaker output. Kind of simple, but also fun project. Now, this version is different, much different. I've never actually seen a version like this before, which is why I was so excited when Pete brought it over. Like, hey, this is a cool thing Pete made. Oh, probably should have the microphone closer to me. There we go. If you can hear me now. There we go. But yeah, we're gonna show this off, show you how to make it, and you can, by the way, find these directions and resources on our website, the code, the diagram, browndoggadgets.com. You can find our maker tape on our website as well as Amazon and quite a few other places online. I think we'll probably post this to instructables.com because it's one of those cool projects we post to Instructables. But
yeah.
If you want to follow us, there we go. Just Pete, stop it. Also, dog below me eating something.
Dog, not me.
It's one of those days. Follow us on these social media feeds.
Yeah,
Thanks, Pete.
Exactly.
Follow us on those. Life is good.
Don't worry, the dog is fine.
He's
fine down
he's
there.
a licky dog.
Okay. All right.
He's trying. Nothing's louder than a dog licking its leg anywhere in your life because that's all you can hear.
Okay.
So let's go to the overhead so we can go to this.
Overhead. So
There we go. So let me move my
go.
clothespins out of the way. So this is the project. I'm going to turn this guy on. There you go. I have a power bank off to the side. And so typically when you see people making an Arduino-based piano, it's a push button to do a sound effect. Here it is. Like a little push button like this, or some sort of push button-esque. Two pieces of like cardboard are coming together. This is one I see commonly. People sometimes laser cut hinges where one thing comes together, touches another, does a sound effect. Now Pete put this together as an opposite. So normally each of these, the circuit is complete here for each of these. It's only when you break the circuit on a certain pin that it makes a sound effect. So you're getting a nice tactile feedback, then it snaps back into place on you because they're clothespins. By the way, cheap clothespins on Amazon are very cheap and easy to have. So we can easily make a piano this way, or again, with other materials as well. If you want to make one where you actually press the button, we have the code version out on our website. We also have a capacitive touch version where you just touch a touch point using conductive tape or conductive paint to do that as well, which is what we do at trade shows. Sometimes with conductive dough, squishy circuits dough, we'll just touch the dough, it plays a sound. Yay, but I like this because there's a nice tactile feedback, and it kind of feels like a piano would. You've got something physical you're pressing against that's different than just a button. As much as I love big push buttons like I threw off somewhere to the side over here. This is a nice tactical feedback, and you can easily say put this on a wall, on a big poster board. This is just on a piece of cardboard hot glued onto there with our maker tape. So essentially we've got our Arduino, our piezo speaker down here. Thanks, #maker tape. And we're using 1/8" maker tape to come up to here. Let me grab, here's my example. And much like we did with our battery tester clothespin here, our tape's just coming up to this junction right here, where the two parts come together. And since our tape is nylon, it can handle the abuse of being bended, folded, and pressed over and over and over again.
Right.
Good old nylon tape.
Yeah.
And then we're using a 1/4" tape here to connect all these together. This is your common ground back over here. And we just have this kind of draped between each of these guys. And I think, Pete, you did too. You used 1/4" both from underside and top side.
Yeah, but a little better contact, wider area of contact, just so we'd make a good connection.
And when doing this too, it'd be really easy just to do that to each of the clothespins ahead of time. Basically, you do everything on the board, yay. Then you get all of these guys made up, each of these clothespins made up individually with the tape already on them. and then just connect them once they're glued into place. So it's not a whole lot to go wrong with it. The tape just overlaps and its connection points. You're good. I mean, it's a pretty simple project, but also a very impressive project too. And also it feels like it can take a lot of abuse.
Yeah.
I'm gonna stop playing with that noisemaker.
Josh, I'll point out two things if I could. So in our diagram, which you'll see on the website, I don't run the tape all the way. Yeah, the tape doesn't run all the way the length of them, like that. I just kind of did that on my first run. I kind of liked how it looked. But you can stop it short as long as you can make that tape connection across all of them, because that's our common ground, that piece on top, and with a little flex slack in there.
And you have that right here. I mean, actually, it does look better on that too. If you're having kids make things up, I mean, it's a project for children. Using an extra inch of tape on each one isn't going to harm anybody.
You could leave it off and write the notes on there, or do something like that. I don't know.
A, B, C, D, F, G, and in the code you can easily change what the notes are as well, because it's just each pin just has a frequency to it.
Yep.
So. You added more from last time I did this. The last time I did only had
keys now, yeah. It's pretty
there
close.
We go.
Pretty close, yeah.
I can do Funky Town on this.
Yeah, that's your song.
Because it works out really well with our base code. That we have all the notes to do the melody to Funky Town on there.
Yeah.
By Lips Inc., which I know, because why not?
You're old?
I am. I'm very clearly very advanced.
Yes.
In my Funky Town age.
Experienced, I think, is the word we
should get that record, because I'm old. Anyway, so we're gonna try to make this. Again, it's not a very tough project. Pete, how long do you think it would take someone to make this? Because you've made now this twice.
20 to 40 minutes.
And it depends on, by the way, you could do 3 keys on this if you want. You don't have to do a full 10. The first one you did was, 5 keys?
I did 6 or 8 maybe, I think, yeah.
I mean, you could add even more keys, too, because the thing is we have all these pins on the back side as well. So you could actually do another, what do you got here? 1, 2, 3, 4, 5, 6, 7, 8, 9. Another 9 pins you could do. So you could do 19, because I guess we're using...
I figured 10 was easy because he's all one side of the board. And you just put the PAs on the side.
That's what I like to do too, when doing things. If you keep everything on one side, it makes things really easy, especially for kids, because then you're just coming down and over. It's very nice straight lines for things. So that's the overall project. So let's go through what you're going to need to make this project and make it look really cool. So
look at that sheet. It'll list everything
you need. The sheet is on here. So... We've got our piezo speaker. Now we're using Crazy Circuits components. You could do the exact same thing here with an Arduino Uno or any Arduino board whatsoever, and just a standard piezo speaker, but we're doing it in our Lego environment with our Crazy Circuits components. So let's go through here. Crazy Circuits robotics board is what we're using. It's one of our cheaper Arduino boards. In the future, we're going to do a version of this using our microbit board as well.
Oh, yeah.
Because why not? It's very similar, and microbit is nice visual drag and drop. Same situation. We'll do that when we eventually get this board finally made.
Yeah.
You're going to need that piezo speaker, and piezo speakers are cheap and easy to have. We have our Crazy Circuits one that pops onto Lego. We're using clothespins, anywhere from 1 to, I guess, 19 if you want to go that far. But 10 is on here, and we're using both 1/8 inch and 1/4 inch maker tape. You also need some Legos as well. We're using a 8x16 green Lego base plate. Doo-doo. And then we're using some plates here to mount the Crazy Circuits board up onto, because the board doesn't have holes throughout the middle of it, so you have to have it mounted up. Or if you wanted to, you could also hang it off the side as well, or just go as far as using a 2x8 plate along the edge. There's a lot of ways you can do it. Lego just makes it easier. If you really wanted to be extra lazy, you could also run tape up and over the top of the holes here on these, because the top is conductive, the inside and the bottom. Just this nicely secures down the tape. It's a nice pressure fit. You know it's not going to come loose.
Gosh, I think that's the plate that's in our kits. Is that right?
This is.
That's why.
We just had 2,000 show up the other day. This fits into our packaging as well. This fits directly in the middle of our packaging. It's also a pretty nice size plate to do things on. It gives us room to put down one of our programming boards, either hanging off the side or in the middle, and then room to work with. And I often make a lot of my projects where I have it just hanging off the side up here and then doing the electronics down below.
Yeah.
But I mean, Lego base plates are common. Everyone's got Lego. I would hope you have Lego. Lego's awesome.
Josh, we're getting requests now.
What?
Can you read that? Play Funky Town again. Wonderful. Kat says she's gonna talk to the music teacher, maybe do a collaboration.
Now, Cat Science Club, also show your music teacher our sound wall. We have a capacitive touch sound wall that Pete put up some fun vinyl cut like stickers off our little vinyl cutter of different musical instruments that you touch, and it plays like a little riff from that musical instrument. You could do the same thing as this with those capacitive touch points, which we've done before. That'd be a capacitive touch piano project just on a wall with tape, and then you could use lots of things as conductive touch point. Not conductive paint, though. Conductive paint on a wall is not as easy as you think it is. It didn't turn out as well as we'd hoped. It was okay. Yeah. But that's a project to look at as well. Anyway, let's get to trying to make a little version of this. And really, since the programming is easy, we have the code up on our website, copy paste it over. We're going to work on this aspect, the physical building of it, because that's kind of the most complicated aspect of the project to do. Otherwise, we'd be here all day. Nobody wants to see me talk for 45 minutes. Unless you're in a teaching conference.
I do.
And you sign up for a workshop. Then that's 55 minutes of me prattling on. To make life easy, you can do one of two things. You can print out this nice diagram and draw things on a piece of cardboard. Or Pete was extra Petey, because it's what he does, and he laser etched this onto a piece of cardboard. That's what he did over here, too.
I did, yeah.
I would just recommend spacing things out with a ruler, mainly to line up all of your clothespins is the big thing. Once you have those lined up, basically your start point and your end point, doing little lines over for your conductive tape isn't that tough to do. And luckily the tape especially is very forgivable. If you're doing this on Lego, it's super forgivable. You could peel it off and put it back on a couple times before it loses its stickiness. Yeah. However, on cardboard, not so much, but you can peel it up and try again. It is conductive on...
Fun fact, Josh. The clothespins you see there, I peeled off of the original piece of cardboard I hot glued them to. I scraped most of it off. But yeah, it's, you know... And I mentioned in the instructions you could tape them down, but as you're pushing them, they tend to move around a little. So I thought hot glue is the best way to kind of hold it down.
So let's prepare a couple of these guys and do a couple of these lined up here. I got my hot glue gun off to my right, heating up, waiting to burn somebody horribly.
Yeah, I burned my fingers, not on this, but on a weird magnet gluing project the other day. It was not fun.
Of course you did, Pete.
Well, you glue one magnet down, you try to glue another magnet down, they stick together, you grab them to separate them, and it's hot glue everywhere, and it's a mess. That's all I can
you think
say.
you can solder onto rare earth magnets, but then you do it and you realize this is a bad idea.
Not going to work.
I've done that.
Yeah.
Also, lose their magnetism, too.
You don't want to heat magnets.
Yeah, they'll lose their magnetism.
Become non-magnets, I think.
Then they're no longer rare. They're just earth magnets.
Science.
Guess it's earth, wind, and fire.
Magnets.
Because maybe to make references to more 70s music.
Yeah.
So
good peel on that tape.
I do a good job. I have many years of training in tape peeling. It was a minor of mine in university.
Yeah.
So I'm just going to start from the underside here. I'm going to go around. Now, I cut mine a bit longer than necessary because I like to show off things.
Yeah.
And just peel, fold around the backside if you want to. This is easy. And I'm going to actually wait to put the other piece down here until I have things glued on.
Good idea.
Yeah. This is a project that's a lot of, I guess you say, grunt work involved. It's a lot of the same thing over and over again, like the time I did a matrix of NeoPixels on a Lego base plate.
Yeah.
It's like 90 little tiny, like, short pieces of tape I had to cut.
That's why maybe 10 keys is better than 19.
I don't know. There are those people who really want to make a nice version of this for a maker fair or something.
Oh, totally.
You could totally do that. And, again, it's how much time and effort you want to put into a project.
Yeah.
A project like this, everybody can make theirs differently, and it's all good.
You know what you could do, Josh, is make a couple different ones, line them up side by side, and then program different notes into them all the way across.
It's true.
I don't know how many notes there are. I'm guessing there's
there's
88 keys.
Yeah, 88 on a piano.
So you could do, that many.
You want to get really funky, you could do both. You have your white keys. You could spray paint some of these clothespins black. Your black keys.
Yeah. The possibilities are nearly endless.
I suppose.
I said nearly.
All right, so in theory, if we were doing this as a full-on project, we'd have our Lego base plate up here, taped in place, glued in place. Double-sided foam tape works really well. Yeah. Double-sided gaffer's tape, a little hot glue. It depends on... Hot glue, at least you can sometimes peel off your Lego plates, which is nice. Yeah. Especially if it's on a smooth, flat side like this. We sometimes have to throw away Legos. Sorry, Lego. And they don't care. This Lego. So this would be on here. So when we started doing this project, we could start our tape from up here and come down and over. Like I'll show you with our 1/8" maker tape, which has come slightly unraveled for some weird reason off to the side here. Let's get you cleaned up. So the 1/8" tape is just like the 1/4" tape. It's just thinner. And much like the Stephen King novel, Thinner, this will soon get used up very quickly. Not a bad movie either.
Right, yeah, no, yep. Mm-hmm. Just watch your alignment with the plate. That was the only tricky part I think I had. But
Yeah, and it's just as long as you get this in the middle.
yeah.
And it's one of those projects you can easily fix. As long as you get, like, I would say too, if you really want to be like, I don't know what I'm going to do, start from here and come over and like leave maker tape with protective backing on it just here on the end. Just
good idea.
Don't peel the tape off all the way, the protective backing. We've done that for a few projects where we don't really know how much we're going to need at the end until we actually got there the first time. But you can just leave the protective backing on.
Well,
now,
Josh, I got to point out again, you can always stick your tape down. If you need to add more, you just stick it on top.
That's a really valid point, Pete,
Yep.
because maker tape is conductive on top and bottom. Now, Pete is not as skilled as I am in the art of doing right angle tape turns.
I'm not.
Whereas I have been doing this for long enough that I am just pretty good at doing it. Well, usually pretty good.
And I do it sometimes, but it just doesn't look as clean. Like you've got the technique down. I don't quite.
I don't know how I got it. It's one of those things I learned as a teacher, do right angle folds.
Yeah, that's crazy.
And now I'm following this. Nice to follow these lines. Now Pete did his with just one piece of tape over.
Yeah.
Same thing, one piece of tape, two piece of tape, three piece of tape.
Yeah.
And again, it doesn't matter because it's conductive on top and bottom. Life is good. And if I wanted to, I could just stop there and then add another piece of tape. I don't really care. And if once you get there, say this is solidly in place, you can then just go up and over your spot and then cut. And always a little extra anyway that you can always trim. It's hard to always use a trim than to add on more. Yeah. Although it's not that much, not that difficult.
Almost equal.
I suppose. We got to cut then, I don't know, whatever. Maker tape.
Cut once, measure twice.
Yeah.
No.
What does Andy see from the other office? Is our audio good?
He said our audio sounds great now that we have the right microphone.
Yeah, we realized that we had switched computers or gonna reinstall, and we had selected the audio coming off of one of the cameras instead of the audio coming off the nice microphone. So me talking to the nice microphone did nothing for like 3 or 4, or I guess most of last week. So
yeah,
sorry, Cat Science Club.
Hopefully we sound better now.
It sounded okay. It wasn't great, but we really like sounding good for everybody out there. I didn't spend a summer at voice acting school for nothing, Pete.
I didn't think you did at all, but okay.
It's between that and clown summer camp.
I mean, a right angle tape summer session, maybe.
Just practice on some 8.5 by 11 paper.
I guess.
There you go. Close enough. That's pretty good. I also am not if I was doing this for a trade show, I'd probably do what Pete did here. Actually, I'll probably use this for a trade show in the future because it looks nice. There you go. I've got a couple of those guys down, and I've got my couple of these. Ta-da! So now we've got to attach everything together. I'm going to put this off to the side. I'm running out of table space. There we go. And I would just do the same thing over and over and over again, making sure things line up appropriately with my Arduino.
Yep.
And there's lots of different ways to connect this. And if you want to change the pin out as well, you can.
Yep.
Again, a lot of easy ways of doing it.
Yeah.
So now we're just going to glue these little puppies down.
Puppies.
Bark, bark. So.
You get enough slack there?
I think so.
There we go.
Old Bernie.
Bernie. That's a good bead of glue there.
Yeah, we gotta.
Yeah.
Call him Sanders. Bernie Sanders. May not have gotten the nomination, but you know what?
Josh, important update here. There's a music teacher watching right now.
Music teachers. Yeah, in that case, I'll speak very slowly.
Wow, really?
In a wonderful C scale upwards. Do. It's been a while since I've.
All right.
My father was a music teacher, by the way, high school music
was?
teacher. Yes,
wow.
He was before he left teaching, like I did. Took after my dad, became a teacher, then left. No. it's true. So once these are glued down, we just have to add the tape between point A and point B. Now, music teacher, I also suggested to Cat Science Club to check out our fun sound wall, which is a project we posted both on our website and a couple other places. We use conductive paint, but we highly recommend you instead using conductive tape with like stickers over it or other conductive materials, because conductive paint kind of is obnoxious.
Yeah.
And we like changing out the vinyl stickers. We have one now, again, I mentioned before. Pete made one up with some vinyl stickers up of different musical instruments. So you touch one and it plays like a little bass riff or a key. We have a keytar up there because keytars are awesome.
I think we got a saxophone, a drum set, a bass guitar, electric guitar, and
acoustic guitar.
Yeah.
And you just little riffs we download off the internet, and you touch one, it plays that thing. And you could do the same thing here. We can just use conductive tape on a wall. I could do this project with conductive tape. And that other one is capacitive touch, where this is a complete the circuit kind of project. Or in this case, break the circuit in this version. We have a couple different versions of things. By the way, email us if you have questions like, these guys sound like they know what they're talking about, but I need to do X, Y, Z, and they're doing ABC. Yeah. Email us. We're happy to either one, point you in the right direction or help you modify something. Because it's not often I get an email or a phone call about a variation of a project that I've not heard before.
Yeah.
Usually they're about solar projects, like, yep, here's somebody already did that or did a version of that.
Yeah.
Or here's the parts you need.
Josh, what kind of teacher were you again?
I was a middle school science teacher.
Science
and
look
social
at this.
studies.
Do you know Amy? She says, "Yay for science teachers." Amy Bishop Bostwick. There, she's
Amy Bishop Bostwick.
Yeah, science teachers, right?
Science teachers are cool. Middle school science teacher. I had a fun time being a science teacher, but I realized I like making things for classrooms when I like dealing with parents and principals and paperwork. Actually, the 4 Ps: parents, principals, paperwork, pay.
Wow.
So you can deal with like two of the 4 of those, but not all 4. And I had to leave.
I think you found your calling.
It's true. I get to sleep in slightly. I don't have to wake up at like 6 a.m. I wake up at like 7 a.m. Instead. So, okay. So we've got this section done up here. And let's bring over this guy. So these guys are solid in place. We've got a connection from the clothespin to one of our pins on our Arduino, like we have here. From Yay, we're good. So now I'm going to connect these guys together across the way. So they're all connected together this way. And I'm going to end here, and then I'm going to come up, and then I'm going to go over. Now we have a piezo speaker here. And we just have the piezo speaker connected ground to ground. It's connected up to a pin there. We're going to fill that out. And then, So this is just, again, the maker tape is nylon, so it can handle the abuse. Make sure you leave a little bit of slack between each one,
a little slack,
because you want to have just a little bit of flexibility. It's the same thing we do with our battery tester one. We have a bit of slack here just so that it can move and bend and twist a little easier. Clothespin tester, another good project to make. So I'm just gonna, let's see, got about a length about let's say about that for our needs here today. Maker tape. Thanks, science teachers, for watching. As always, all of these projects and resources and guides and code and diagrams are free on brown.gadgets.com. And if
Josh, do we have anything we could give to teachers besides all our wonderful resources, lessons, curriculum, plans?
Our love and support?
Is there another?
Oh, we have all the things we sell.
Well, right, obviously. What if they wanted to try this maker tape? Is there a way to do that?
Oh, Pete, I see what you're getting at.
Yeah.
Here's the thing: if you'd like to try some of our maker tape, we frequently send out free samples to schools and libraries. If you want to try one out, little small 5-meter rolls of tape we like to throw out there for teachers to use and try out. Really, especially if you use copper foil tape already, try out the nylon tape and see what you're missing, because this stuff is it'll change the way you're going. So Amy, email us, Amy, off our website, brown.gadgets.com.
She might do that because she loves freebies.
See, as a teacher, I know how it goes.
Yeah.
I've been to teaching conferences where I see what I call the pack mule teachers. They're the teacher who has like 4 or 5 big swag bags. We're not like big tote bags.
Yeah.
Just jammed full of stuff. And they're the ones that are there like minute 1 when the floor opens because they want to get all the freebies. Now, granted, like NASA always has really nice big posters. There's lots of fun freebies at teaching conferences. Yeah. Unfortunately, we can only really give away tape with our marketing budget, which is live streaming and giving away free tape.
Yeah, but a teacher like that they're gonna use everything probably in their classroom. I mean, that's what teachers are kind of known as, being very resourceful and doing what they can.
So then we would go from our 1/4-inch tape to 1/8 inch to then connect to what would be the common ground. on here from our circuit. The little white circle spots on all of our parts are the ground. So that's always the common connection. And so then we have our circuit connected here. I'll add some 1/8" tape on here just so I feel like I've completed the circuit, even though I'm not going to attach any electronic parts to it. Because, again, we'll be here all day.
Plus, because our switches are normally closed, you'd have 8 open switches if you connected up the board now.
Oh, that's true, yes. Yes, because we don't have anything connected to those spots.
Right.
So if you want to do less, I guess you have to delete lines of code.
Yeah.
Is really what you'd be doing. So I'm going to start here, which would be my spot for ground. Yay, over, and then just, as long as it's touching my tape, ta-da, solid connection, because it's awesome tape.
Yeah.
Maker tape. So, which note to self, I have a couple samples to send out from last week that I didn't
note
send
to
out yet
self.
because
Yeah,
our
let's
warehouse
get those
manager
out
is
this week.
not here last couple days. So anyway, this is basically do the same thing over and over again to connect all these guys together, and then you'll have magic. Ta-da! Thanks, Pete. So that's how we do the clothespin circuit. Now you can do also fun things too. I know in the past when we do sound things, we often like to add some light effects as well. So it's sound and light. We helped a group of students from a school for the deaf with a project, but instead of doing our touch piano, it was touch a thing or push a button and an LED turned on. It was a light piano, which was a modification they asked for, and we were like, we're halfway there anyway with our LEDs. Let's just add more into the code. So just little modifications so they could still do that activity. Simple and easy. You could do lots of different things with this. So I'm going to turn this on again and play Funky Town.
We got a quick question, Josh.
From Randy.
As the adhesive side, same resistance? Yeah, answer would be yes.
Randy. Oh, man. With your Trojan horse picture there, I like it. So, Randy, cool. It is actually just fine. There's resistance between the top and the bottom with the adhesive side. It doesn't add anything to it. Not on our testing. It should say there is a very, very, very minor amount of like 1 to 3 ohms, but I can't tell if it's our margin of error in our testing with our off-the-shelf multimeter or if it's the tape. Basically, in situations like what we're doing here, all these different projects, it's never been an issue. It's such a minor amount of resistance, less than 10 ohms, that we can't tell. If you want to get really fancy, we have a video up on YouTube of us doing stress tests on our tape where we hook up a power supply to it and see how much amperage and current can these little guys handle. It's fun. Oh, making sound effects. Also, the wider aspect, it doesn't matter. We just went this route because that's a bit stronger, just a little bit stronger tape.
Yeah.
I mean, the 1/8" and the 1/4", there's no difference. It's the same tape, just cut thinner. The 1/4" can obviously handle a higher amperage. If you watch the video, it does handle a higher amperage of power, but by the time you're at 2 amps for a student project, it's a bit of electricity going through there.
Yeah.
Like 1.5 amps versus like 2 amps max kind of on stuff. But that's way beyond what most people are doing since we're doing 100 milliamp.
Yeah.
Like using a coin cell battery, which is 10 to 20 milliamp of current.
Tiny, yeah.
But yeah, it doesn't matter. We could do it with the 1/8" as well. We just did this for the ease and just a little bit more strength.
Yeah.
And
Josh, I noted in the instructions, if you only had 1/8", you could use it, but really the connection inside there, you want a little wider just so you have better connection point.
Yeah.
You know, if you did 1/8", you maybe took double wide or something.
And even Randy, I would say on projects where we needed to have like a wider area, like a bigger area of tape. Oh, we have our piano tie. We actually have a little capacitive touch piano. It's a piano tie. You touch it and play sounds. Forgot about piano tie. It's up on the shelf over there. We actually just overlapped several pieces of 1/4" tape together. We don't sell thicker or should I say wider versions of tape. I have a couple rolls of 1" wide I just got to try out from a manufacturer, but we just overlap these guys, or we just put them side by side and run a piece of tape across the top to connect them all. I've done the same thing with big sheets of aluminum tape from Home Depot. That stuff is great for making a big like wall-based or big cardboard-based piano. But since the bottom is not, the adhesive is not conductive, just kind of overlap them and put them side by side, then run a piece of maker tape across the top or bottom. Now they're all connected. So just simple ways to handle things. Because I know adhesive on most conductive tapes, even the copper foil that's supposed to have conductive adhesive, is never super reliable. We made a lot of time and effort into getting this to be very, very, very reliable so that we never question it. And we have done circuits where we've had 5 or 6 overlapping pieces in a row and the connection's fine. I think we had a video game controller. We had a lot of little tiny connections all over the place, and not an issue. It's reliable. The only issue you run into is just like some issues with like just surfaces you're putting it on. This can handle most surfaces. I know. Really, it's moving and adjusting it. It goes on to pretty much anything just fine. It's when you want to peel it off of like cardboard. It's gonna be messy. Fabric. If you have something super fuzzy, like cheap felt, the cheaper the felt, the worse it is. But like thick felt works really well with. It'll come on and off pretty easily without destroying things. We have a lab coat over there covered in it. Comes on and off fine. Any hard surface, it comes off in one pull. So it's a good thing. Randy, if you want a free sample, email us, because teachers and librarians ask and we'll send you a sample. My only verification is like typically sending it to a school or library directly. Is like our verification of that you're from a school or library. Not that we keep track of these things all that well.
Josh, another question
Cat
here.
Science Club.
Have we put any outside?
No, that's a really good question, Cat Science Club. I can say inside, we've had it up on our wall for like 2 years at one point before I peeled it off. And that was going through the hinge area of a door, and it didn't break. It just took off a little bit of paint because it's been stuck up there for a long, long time.
I mean, it's nylon, so it's pretty tough.
Here's the one thing that's going to happen. So it's the same issue you have with conductive thread. Because I've broken out projects that we made 4 years ago with like the first versions of this tape that we had. And I could definitely tell it was a darker color because it had slightly corroded a bit. Now the project still worked fine. Oxidized. Yeah, there we go. Yeah. Oxidation. Project worked fine. But it's the same issue I've heard from people. Becky Stern from a well-known maker person and awesome creative individual. I talked to her at an event. She said she was kind of overdoing conductive sewing projects because she'd make these really great elaborate sewing things with conductive thread. And then she'd come back 6 months, a year, 2 years later, and they'd all oxidized and the connections were poor. Because it was just not even a pressure fit like we have. It was just a tight contact fit from sewing stuff. And I totally get it, and it does lose some goodness over time because of it, but our projects were fine and our tape is wide, and what we're doing, I mean, it's much more surface area, much more material here than with a thing of conductive thread. So I've never had an issue with our old projects, but again, we've had them in a box or taken them to trade shows for a few years, but definitely I can tell they have oxidized over time, just that darker color. And yeah, even the stuff we have like in our warehouse, like we keep in the box, it's wrapped in plastic for like the few months we have it on the shelf, and it's fine. But I don't see why it wouldn't hold up pretty well outside over time. It's just that it would have a limited lifespan, and depending on where you are. You're in Arizona where it's nice and dry, probably way better than having it, in Hawaii where it's got 90% humidity all the time, which is why floppy disks kept getting destroyed in Hawaii back in the day. High humidity.
Josh, I'm going to volunteer you send me to Hawaii with some tape. I will test it. I'll stay there like months, a year, whatever it takes. We'll find out the truth.
We send you to Seattle. I hear it's like a rainforest.
Also, we've got a question here. So is it pitched? So we and we said you can change those notes, but we selected. I use the same notes as on that old piano we did.
Yeah, we just chose like a range of notes to work from an octave, and you can change what pitches those are in the code very easily. It's just, if I'm not mistaken, in the code, it's just there's a number which actually is the frequency of it, and you can just look up what is the frequency of A sharp in this octave.
And we have a link too to that chart that shows you put in whatever numbers you want.
You just copy paste that number over. You've got that. This is now A sharp in that octave. Or whatnot. You can just very easy to change. No coding needed. You're literally just changing like pin 1 equals this number. Pin 2 equals. If you have no idea how to code stuff, it's all good because it's just copy pasting a number. And if you screw up too badly, just copy paste the original code off our website back in again and start over. We try to make things simple because we understand how it is when you're not familiar with this stuff. I'm not a very good coder. Pete does a lot of the coding for us, if not most of it.
Josh, I'm going to in a second. So have you ever had one of those, like a battery leaks acid and it kind of gets corrodes the little connector? So that's kind of a neat idea. Maybe you could put the maker tape over the corroded part to slide a battery in and fix that connection.
Yeah, especially like AA and AAAs. I think AA's max out like 1.5 amps of power.
Yeah.
Like it's definitely within the power usage of this. Or if you wanted to get really fancy, I've kicked around other like battery holder ideas because trying to put batteries into systems, especially AA's or AAA's, can sometimes be annoying. We use easy battery holders and screw terminals for our Lego system. We have little Lego screw terminal things. But you could just run the tape to the back of a battery, to the front of a battery, like a AA, front and back, and you're good.
Yeah.
You could just do it that way, but you could use it for other patching systems. The guys from Qubits, which is another STEM ed company, we sent them some tape for a project they were working on. They made an antenna, a TV antenna with the tape.
Yeah, that's right.
Like a digital TV antenna, and he actually did a comparison on his Twitter account of like a off-the-shelf like retail one versus the one he made, and a couple different designs, like 3-dimensional, this shape flat, and he picked up quite a few stations, which was really cool. We've used this as well for making our own homemade speakers with as a project, using an amplifier or just a cheap amplifier receiver, and then making a speaker spiral or a square spiral with a magnet underneath to make sound. It works pretty well for that. It's just when you have like your iPod cranked up all the way for your input and then the speaker turned up all the way, the one we have, like our tape, it got hot. Like you feel like it hot. But it was much, much easier than trying to do that with copper foil, because we could do right angle turns really easily with this. Really, 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 really easily with this without having to worry about the tape breaking, which copper foil would be a nightmare with that. But there's a lot of good uses for this. I mean, it just depends on what you're doing. We use it for wearables as well, again, on like lab coats or shirts for like one-day wearables, because it'll peel off when you're done, as long as it's not like a super fuzzy sweater or something.
Yeah.
Say, if something you really, really love, an outfit or a shirt or something, don't put it on.
Yeah. And Josh, I'll point out again, this is one of those projects where I don't think I could have done it with the copper foil.
Oh, no.
This is perfect for maker tape.
Well, it's the flexibility and the abuse.
Yeah.
That you need to have the strength and the abuse. And the 1/4 stuff, I always say this, as an adult male, I have a very difficult time ripping the 1/4 inch by hand. Now, I can brute force my way through the 1/8 inch if I just, but great sound effect there for me. But you really want to cut it with scissors. Now, for kids, they could be able to rip through either of these very easily, if at all. So it can handle that, and which is really, really nice. It can handle the flexing and folding of being on fabric or this over and over again. It's nylon. It's good enough for parachutes, good enough for you. Seriously, it's nylon. It's super strong stuff. We have another question there?
We do. We have. I'm going to give you this one right here. Can you read that? It seems like this is better than...
Randy, it is.
You know what I'm going to say here.
Maker tape. And if you have something like a makey kit already, now, nothing is the makey. I never found a great use for my classroom beyond doing a banana project with bananas. You also have the issue too with the makey. You have to have a computer for it to be useful. And in the school I taught at, we had 1.5 working computers, I want to say, in my classroom. And I had 30 kids in each class. So having like 20 makeys, which we were given at one point, was kind of useless. A lot of extra that collected dust. But yes, it's definitely a better option than copper foil. In general, no matter, the best copper foil tape in the world will not be as strong, anywhere near strong, useful, wide range of applications as like the worst version of this you could get. And we make sure that the version we get has that nice conductive adhesive. We worked with like a tape manufacturer in China to just kind of tweak the formula a bit on a couple things. Still cheap enough for us to manufacture, but works a little bit better than the kind of standard stuff that you'd find out there. I know for a while tape was being used for fixing electronics as like EMF shielding, or fixing parts and whatnot. But we just modified it so it would be much more classroom friendly, which is like half the things we do is find parts like how can we make this more classroom or kid or adult friendly, because some parts just are not that useful for the average person unless you have some minor modifications to them. But it's definitely a better thing. And seriously, Randy, ask us. We'll send you a free sample. You can judge for yourself. Yeah. We're always happy to do that, because like sending stuff out of the Qubits guys, it's just, they did the whole like antenna thing with it. I would have never thought about doing that. Andy, our curriculum writer, was like, hey, I bet we could use these for speakers. And we did it, and it turned out awesome. There's so many different things we haven't tried. We even done wireless power transfer with it. With like two like toilet paper tubes, essentially, kind of like those cardboard cylinders. Andy, our curriculum writer, tried like several versions of this to varying degrees of success, just wrapping like loops and loops and loops and loops of tape on it. Then he put like a layer of clear packing tape over it to another layer, so they were separated. They weren't electrically touching each other, but they were still layered. and we were able to get like very, very like short distance wireless power testing between the outer layer of one tube to the outer layer of another. So they were separated by basically a layer of cardboard. But we had wireless power transfer. We got an LED to turn on. It totally worked. It was way too much effort. Like, we never want kids to do this in a classroom. It's just, well, it's this project. It works. It's too much effort. No teacher kid wants to put that much time and effort. There's so many things that could go wrong, even on a minor level, throw the entire thing off. That's just, it did not work as an activity, but it worked. So we did wireless power transfer. The speaker one was the best, though. The speaker did, because it was, we could do it on a bunch of different surfaces. We have a couple videos up on our website under our step-by-step guide on how we did that on our website. Oh, brown.gadgets.com, free resources for that, and diagrams and whatnot. You can use copper foil tape with this project, too, if you wanted to, but it won't work as well. Randy.
Josh, we've got this. I believe he's asking, can you use a Raspberry Pi?
Yeah, why not?
For this sort of thing.
Literally, so I've seen people take like a standard Arduino or a standard microbit and just run tape from here off to a piece of paper. Sure, it doesn't matter. It's really, just think of it as like it's a wire that's a piece of tape. Yeah. If you think of it that way, like I could run a wire across my ceiling, or I could use a piece of tape.
Yeah.
For low power applications, sure, just fine. Doesn't matter. If you think of it that way, then you're like, oh, I could like a sticky wire that has up to 2 amps of current can go through it.
Wire.
It is a sticky wire.
Sticky wire. That's a hashtag sticky wire.
Is that your new band name, Pete? Sticky wire.
Hey, you got to start playing, Josh. People want to hear things.
I can't play that. No. I say I'm missing some notes here. Anyway. I was never good at piano.
Better than I am.
Violin fingers. Not played strings, not a percussion, as my spouse points out. Pianos are percussion instruments.
Yes, indeed.
Yes,
indeed.
But no.
Wait, we've got someone asking you to play.
Speaking of the devil. Thanks. Spouse is watching things.
Kat mentioned, so scissors is one of the things typically you'll need if you're working with tape.
And even like your small standard blunt edge classroom scissors work fine for cutting it.
Yeah.
Just think of it, it's a sticky conductive fabric tape, and it works on any surface. Cat Science Club knows, they're cool people.
Yeah.
But no, so we have these resources on our website. Pete just posted this project today. We post a few new projects a week in varying degrees of project build guides. Some of them are very, very intense. Some of them are just like, here's a diagram, here's an example video. Something like this doesn't really need a whole lot of hand holding because it's pretty darn simple. We give you the code and all that fun jazz. You can find our parts at brown.gadgets.com, on Amazon, through pretty much every library and school supply catalog out there. Your Demcos, NASCOs, Ward Science, Gopher Sports, STEM Supply. If you're in Canada, B&B or Spectrum, they carry our stuff. Robotshop.com just started carrying our stuff. And they have warehouses in both Europe, Canada, and the U.S. Oh, and Asia, too, and Japan. So if you're a Japanese person, I could say, konnichiwa.
Josh, we've got a new challenge from my old friend Bill here. Could we use it as a theremin antenna?
I don't know. I mean, I do love a good theremin, don't get me wrong.
Yeah.
We all do. And we've done like our pseudo theremin, which like a light with a light detecting resistor.
Yeah.
So it's based on light sound effects. People have to do that with like a 555 timer or two of them. But we just use an Arduino with a piezo speaker and a light detecting resistor, and just move your hand, light and dark changes the sound output. A theremin antenna, I don't know. I have so little knowledge of how an actual theremin totally works. The world's first truly all-electric instrument.
Yeah, right.
Yeah, it is. Yeah, the theremin.
Well, Randy's got one more question here. So
yep. Use instead of conductor thread. Randy, if you go to our website, we have a really great bracelet activity. Like, it's our no-sew bracelet, because we do like conductive sewing. Like our Lego-based parts, we've one of the things we sell with our kits is actually conductive thread, because you can sew onto these parts up much easier than, say, sewing onto your standard LED. Where's one of my guys? Here's one. Like our little battery holders. They work really, really, really well for sewing. The problem is it's sewing, and most kids just aren't good at sewing these days. And most adults aren't either. I've been in a room with kids and adults had as much trouble as the kids did threading a needle or sewing things because adults just don't know how. My Boy Scout sewing skills from, 18, 20 years ago, I just haven't used them that much. And I know enough to make a simple activity or whatnot, but doing like a sewing bracelet versus, say, a conductive tape bracelet, it's just so much easier. I always say when doing conductive sewing bracelet, an LED, 2 button snaps, and a battery. And a piece of felt, just super simple with sewing, takes about an hour and a half for, say, middle school kids or even high school kids, unless they have previous experience sewing. It really is sewing on 4 buttons, 2 snaps, an LED, and a battery holder with special thread. And you have to hand stitch it. You can't. There's no reason you can't use a machine. But so we have a no sewing bracelet using conductive tape, regular LEDs, and a regular battery. Basically as cheap as you possibly can get for doing a group activity with kids. Because I can tell you that when kids, especially younger kids, 4th, 5th, 6th grade, even into middle school they're more interested in decorating and personalizing their project than they are about the electronics. Yeah, it lights up, that's cool.
Yeah.
But decorating it, making something uniquely theirs, Randy, you could have a dinosaur in yours, I could have a squid on mine, Pete could have, I don't know. Cats.
It's going to be a cat.
Cats. It doesn't matter as long as the circuit works. So getting them that wonderful, they made the circuit, they understand how it works, yay. Get to decorating, that's important, as opposed to sitting there hand stitching for an hour and a half, having an adult check it over and over again, trying to thread needles.
Right.
It's something I hate having people do because it's so tough. Only Scouts and like 4-H do I recommend if the kids have done sewing already. Otherwise, I try to really push them to do other things. I'll sell them parts, but I always give a warning, like my experience and for classroom management and for large group activities, go the tape route instead. Because if you mess up, just peel the tape off, try again. It sticks on well, holds together well, and you can use a plain LED, like our 10 millimeters here, just a plain 10 millimeter LED. You can even tape the battery down because we have a way of using a tape loop or just attaching tape to the battery directly. You can replace a battery easy peasy and still have a wraparound with a sticky switch or a sticky connection on there using the tape. And heck, you could, if you want, you could do half and half. I have somebody who used our 1/8-inch tape on a bigger sewing project and then went over with a zigzag pattern with a sewing machine because they could really secure it down. And that's, it could, again, it depends on your project. And some people make some great conductive sewing things, but you spend so much time sewing. And even us, we have done multiple of the same project with sewing before. One worked, one didn't. We could not figure out why the other one didn't. All the parts individually worked just fine. All of our connections look solid. Fabric is rough because it's a 3-dimensional, very movable, non-standard thing. I can throw this across the room. It's not going to lose its rigidity. A shirt is easy to get a cross connection.
What about ironing, Josh? Have you?
I don't know. Randy, give it a try and let us know. I don't know. I don't think it would do much better. I mean, unless you'd melt the adhesive slightly, and I don't know.
It's sticking on that lab coat great. I've seen it stick on other, fabrics really.
It's been at least 6 months since we put on that lab coat across. I can see it from here on our door across the room. It's on that lab coat fine, and it's just been. We wore it, took a few photos, and put it up there.
I think maybe something stretchy would be a little weird because. But
I'd say the more rigid the material, the better. Like shirts, most shirts are just fine.
Yeah.
But it is, heavy felt is what I like to use. I don't have any here, but we have some like nice thick felt. You can even use stuff like conductive Velcro with it. I have a piece of conductive Velcro here for some weird reason. Oh, here we go. This is like the thick felt. There's a couple layers here. We just get this off Amazon for our projects, but it's just some nicer, thicker felt. And there are lots of grades of felt. You get the stuff from the dollar store. It's basically tissue paper. Michael's Craft Store has some decent felt on there, but we found some nice, really rigid, stiff felt, which just not very fuzzy. Just it worked well. Pete laser cut this, by the way.
I did.
It's our internal motto: don't add Wi-Fi to a cupcake. As a reminder to not overcomplicate things.
Cupcake Sounds Wi-Fi. Now, Josh, very exciting. Our friend Maker Block says his tape came in.
Yay! Thank you for ordering.
Yeah,
we're having issues with COVID-19 and our local post office not being able to ship things.
Yeah.
They'll go out, but it takes like a week to get from one part of Wisconsin to like 10 miles away from where we are.
He'll probably do something cool, and when he does,
you can share
I'm sure we're gonna see it shared.
Yeah.
One of these
if you have a cool
places.
project you've made and like to have us talk about it and show it off on the internet, please send it to us.
Yeah.
We'll share it on our wonderful social media channels. Please follow us because we just post projects on there. That's literally like, check out this cool thing we're working on, and it lets you know when we're live streaming. We don't do a lot of coupons or crazy advertising. Every now and then, like, hey, we're having this special on this thing, or we have a new product. But usually it's just check out either cool things other makers are making, and even then it's not often that we, once or every couple of days, like, oh, I should share something. But all the projects, Pete and I post pictures of the things we're working on. Prototypes we're working on as well on there. This is our prototype microbit board, one of them.
And Josh, we're open to ideas. So I know Bill here said theremin. I should have been listening to the last couple minutes, but I actually came with an idea for making theremin using our parts.
Yeah.
So I'm gonna do that coming up soon.
We get a lot of good ideas from other people, like, hey, could you do this? We're like, no, we could do something similar to that.
Maybe. Who knows?
Oftentimes, we try to keep things in a realm that is doable. We actually pass up projects even internally that, like, that's a really cool project. Like, yeah, but it's so over the top that no one else will be able to replicate it, or you have to have so much specialized equipment. Even for laser cutting things, I sometimes feel bad because laser cutters are not a most common thing to have around. And we use those for some of our like solar projects and custom parts every now and then, even just laser etching on here or laser etching felt for Pete's Gate. But I feel kind of bad doing that because I want to make sure that anybody who sees a project that we have can actually replicate it with our parts or with some of ours and like off the shelf components or just even off the shelf. Like you do off the shelf Arduino parts for this galore if you wanted to.
Yeah.
Our maker tape is going to make it a lot easier. We have our nice Lego setup with our parts. We love when people support us. Keep it simple, Steve.
Yep. Yeah, Josh. So like I mentioned, I did the laser etch version just because it was easy for me. But you can cut it with a knife. You can mark it with a pin. There's a lot of sort of different levels of what you can do. So
To quote my toddler,
yeah. That's right. Yeah.
Toddlers. But no, any questions, email us. Again, Randy and others, email us and we'll send you a free sample of tape. We're seriously happy to do that. Check out our free resources at browndoggadgets.com. We're here like 3-4 days a week, depending on the week. I think tomorrow we're doing a dark detecting circuit on paper using transistors and a light detecting resistor, but with Make Magazine. We're live streaming for them.
We'll do that tomorrow.
Again, using a transistor on paper with our maker tape. And we're just a simple dark detecting circuit, tape parts on a piece of paper, keeping it extremely simple, extremely inexpensive. And it's one of those things, too, teachers who have to send things home now for kids to work on. A transistor, an LED, a light detecting resistor, a couple of other resistors, a battery. It's inexpensive parts. You could have kids making several projects for a couple dollars worth of materials and a small roll of our tape. And that's great.
Bill's got another
comment William. Yeah.
That's a good idea.
Yeah. Cheater tape. I like that. Cheater tape. It's not cheating if it's tape. It's true. A conductor thread's great. I like the idea of doing wearables. I think wearables are a great thing for people to do and make because we all love wearing and showing things off. Gosh, Halloween and ugly Christmas sweaters, if nothing else. But that conductor thread can just be annoying. And even people like Becky Stern when she's an like so much of an expert on wearables. She's like one of the I would say top maker experts out there on wearables. When she's frustrated with thread, you have to know like it's getting to people. And I really hate having to like try to do workshop the teachers. I always try to move them away from there because unless you know what you're doing sewing wise, it just adds that other layer of complexity on top of things that shouldn't be there, especially with kids. And you want kids to have a good time and learn and be successful. And success builds that motivation to try more projects. But yeah, totally agree, William. It is frustrating. We've been frustrated. We've thrown things out before. It's like we're done. Robin, who came by, Robin Lawson used to make a lot of big projects for us. Made this great interactive like NASA shirt. I think she spent like 8 hours of sewing on that, just hand stitching. It wasn't that many LEDs either, but she had like capacitive touch areas on the shirt. You could touch the NASA lettering because she had stitched in there. You could touch it, it would change the pattern of LEDs. And we've had it at trade shows where it's just sitting like on like a half mannequin body, like just a mannequin torso, and it just stops working. Like there's a short circuit that happens and no one's touching it, nothing's happening. It's just like, thread. And it's thread-based issues. It's in a box somewhere because we're like, no more. We have other things we can show off now. Wearing lab coats with light-up stuff on it is a little more attractive to teachers and people at Maker Fairs. So, and people email us. We're happy. We'll be around with Maker Camp tomorrow, browndoggadgets.com. Email us. Call us if you want to. We have a phone. People call us and ask us questions. We're happy to chat. And
right.
thanks for watching Cat Science Club. We'll
Yeah.
see you later because we like you. But with Make on their channel, then I think Thursday we're going to be doing something. I don't know what we're going to do yet.
We'll do something.
I mean, we showed off like some cool
We did
projects last week, other Arduino projects with our free curriculum we have. By the way, free curriculum for Arduino stuff on our website that we're posting and writing and doing all that fun stuff with. But we'll have a cool project by Thursday to show off one of the things we've done in the past.
Yeah.
Maybe more Clothespins projects. But anywho, yeah, we're moving forward with our microbit component. And so many Lego things we purchased to go with it. But we're out of here. We got
All right,
paperwork.
we're
You
good.
buy Cat Science Club because I know you're messaging. I see you over there. But we
Okay.
appreciate everyone watching us. And this is a cool project. I hope somebody else makes it and shows it off and shares it with us because we'd love to see people making our stuff.
Yeah.
Even if you're using standard like parts you already have, awesome. Share a picture with us. We'd love to show that off. So see you guys later. Thanks a bunch
right.
and bye.
Thanks for watching. Please visit browndoggadgets.com for parts, projects, and curriculum. Follow us on social media at browndoggadgets. Check out our live streams at Facebook, YouTube, and Twitch. We'll see you next time.